Hey guys, we are entering the very last unit of geometry, which I'm sure you guys are excited about. Hope you guys are dealing with the online learning well. Make sure that if you have any questions to contact your teacher so that they can assist you. But we're going to get started with probability. Today is a focus, or this video is a focus on set notation. You guys have seen Venn diagrams before when you're comparing and contrasting different artists or whatever. You could compare Tupac to Biggie. It could be in literature. It could be in social studies. You've seen them before. It's the same concept in terms of probability, but there is some new vocabulary for you guys to know and some visualization to help you guys out when you guys get to the Venn diagrams. So let's get started. This sheet is located in your GoFormative if you want to download it, or if you want to pause this video really quick and copy it down so that you can follow along with the video. So feel free to pause whenever. All right, first thing we're going to talk about is union. So union is, say if you're thinking about a marriage of two people, it's a union of the two people. So union, this looks like a U. So U for union. And it's everything in both sets. So if two people get married, they bring all their stuff together. It's everything in itself. So we're going to shade everything about A and B. So our solution set to this is 1, 2, 3. And we write it with this little bracket. And then make sure you close it. So this is how you show your answer for this. And then now let's go on to intersection. So this looks like an N for intersection. And it's just like how you picture it when you're talking about intersection in the real world. So if we're talking about a road, and forgive my drawing, I'm not an artist, but if we have two roads intersecting, the intersection is where they overlap. Same thing happens when we're talking about sets and probability. So our solution set to this is just 2. It's only where they overlap. So this is our solution. Okay, complement. You could see it either way. Make sure you're familiar with both. It means not. So everything that is not a part of that set. So if A is this entire piece, this whole thing is A, and we want not A, we're going to shade all around it. So not A is 3 and 4. So remember, complement means not. Okay, this is where it gets to be a little tougher, not too bad. But this says not the union. Remember, this means union, A, union, B, but this says not. So we want not the union. So if the union is everything that's in A and B, which is all of this, it says we want not this. So what's the only thing left? This outside area. So this is not the union of A and B. It's just that outside set. That's the universal set. So the answer for this one is just 4. Lastly, it says not the complement of A and B, so not the intersection. And so, sorry, not complement, not the intersection of A and B. So the intersection is where they overlap. We want not that. We want everything else outside of it. So we're going to shade every bit outside. So the answer for this one is 1, 3, and 4. So this is the, big vocabulary you need for set theory. All this shading and stuff will help you when you're talking about Venn diagrams. So now we're going to do some examples. Okay, so C if we look at this one, we have the universal set, which is the outside. So it's all inside the box. Everything that's inside this box, that's the universal set. And we can see that C is all the way inside of A. So set C is a subset of set A. And all that means is that all of C fits inside of A. So when you start with filling in Venn diagrams, I always say to start with the subsets and the intersections, because we're not going to write the same number multiple times. It's only in the universal set one time. So if we look at 3, I see it's in both set A and C and the universal set, but we're not going to write it 3 times. It's only in this universal set once. So start with the subset. Subset C, we said all of C is in A, and here's why. 3 is in A and C, and so is 5. So we're going to write 3 and 5 inside C. You can cross it out or underline. I highly recommend doing something to show that you've already done it. And we're also going to cross it out in the universal set because we don't want to write it again. Now let's do the intersection of A and B. So looking for numbers that are in both set A and set B. And we see how we have an 8, a 9, and a 10. Is there anything else? No? Let's cross it out of our universal set. And now we have just what's in A that's not in the intersection and in the subset of C. So 4, 6, and 7. And we want to cross it out of the universal set as well. And then we have set B, which is 11 and 12. Cross it out of the universal set. And there's a couple numbers we have not used. So we are going to highlight those numbers and make sure we put them in the universal set, so the outside. So we're left with a 1, a 2, and a 13. And we just write those outside the Venn diagrams, but inside the universal set. Okay, well, what happens if I have 3 circles? Start with the very center and work your way out. Easiest way to go. So we want to find out what's in common in both sets X, or in all sets X, Y, and Z. So there's an A in all of them. Not a B, but there's a C in all of them. And that's it. So now let's look at what's in X and Y only. So X and Y only. Oh, and let's make sure we cross these out of the universal set. X and Y, we have an E, and that's it. What about X and Z? So X and Z, we have a B, and that's it. And now Y and Z, there's an H, and that's it. So let's cross those out of the universal set. We had a B, a D, no, B, E, and H. So we cross those out. We've written everything that's shared in all 3, and then each pair of circles. And now we write what's left in each one. So what's left in X, and it's just a D. Also, make sure you cross it out of the universal set. What's in set Y left? We have an F, K, M. And what's left in set Z, J, and L. And then lastly, we do the universal set. So what is left in those pieces? And we have a G and an I. And that's it. So again, start with the middle and work your way out. So now that you know how to build a Venn diagram, let's answer some questions about it. So here's a real world example. And this says, how many students did homework? The answer to this is not 5. We want every student that did homework. They could have done something else, but we're concerned about if they did homework at all. So how many total kids did homework? 3 plus 3 is 6, plus 2 is 8, plus 5 is 13 students did homework. Now comes how many students played both sports and an instrument. And it's not one. We want they did a sport and an instrument. They could have done homework, that's fine. But we're just concerned about those who did sports and instruments, period. So 2 plus 1 is 3 students. It didn't say how many students only played sports and an instrument. It just says played them, period. Okay, next is how many students did all 3. So this is where all 3 circles intersect. And that's this part right here. So only 2 students did homework, played an instrument, and played sports. Last question, how many more students, so more, you're trying to find a difference between, which means to subtract. How many more students played sports than an instrument? So we need to find out how many total students played a sport and how many total students played their instrument. So we have total sports, all of our sports, 6, 7, 8, 9, 10, 11, 12 students played sports. And how many played an instrument? Sorry, that's hard to see. How many total played an instrument? 3, 4, 5, 6, 7, 8 for an instrument. And then from here, all you do is subtract. So 12 minus 8 is 4 students. You also could have noticed that right here, these were included twice. They're both in instruments and sports. So you could have done 6 plus 3 is 9. And 3 plus 2 is 5. 9 minus 5 is 4. So you could have not included this intersection and just counted those numbers. Either way, you would have gotten the same answer. So this is Venn diagrams with probability. Next, you're going to talk about or learn about two-way frequency tables, and that's it. So this is just a basic introduction into probability. You've seen a little bit of it. Venn diagrams is not new, but some of this that we talked about is new. So make sure you guys do the practice so that this gets easier for you. Hope you guys are enjoying your digital learning.